All right. So like I said in the last lesson, we looked at what makes any old quadrilateral a parallelogram. And now what we're looking at, what makes a parallelogram a rectangle, a rhombus, or a square. Okay? Now, you could have just a plain old parallelogram. It doesn't have to be one of these things, but it could be, right? So let's look at the properties. So first of all, what you want to know is that just a plain old parallelogram has one of their properties, we're just going to say, is that both pairs of opposite sides are equal, but consecutive sides might not be. The other property you could say is that opposite angles are congruent, but consecutive angles might not be, right? That would just be a plain old parallelogram. What makes a parallelogram a rhombus is when all four sides of the parallelogram are equal. So not just that the opposite sides are equal, but all four together are exactly the same length. That's a rhombus. A rhombus does not have to have all equal angles as well. It can, it just doesn't have to. A rectangle may not have all equal sides, but it has all equal angles, which in a quadrilateral, remember, what does any quadrilateral have to add up to in angles? 360. It doesn't have to be a parallelogram to add up to 360, right? It just has to be a four-sided figure to add up to 360. That's true all around. In this case, we're saying that we're evenly dividing that 360 between the four angles, which would mean that they would all have to be 90 degrees. A square is the combination of the two. Oops, I'm sorry, guys. I did not mean to do that. Give me 1 second. There we go. A square is the combination of the two. So a square has all equal sides like a rhombus does, and it has all equal angles like a rectangle does. So it's the combination. Okay, so what we're going to look at now is, hold on 1 second. All right, so we're going to look at other properties of a rhombus. What did I just tell you is the main overriding property of a rhombus? So that's one of the properties, is that a rhombus has to have all equal sides, right? And we're assuming each of these has already been classified as a parallelogram, so these properties really only work if you know it's a parallelogram, okay? You can't just take any old quadrilateral with the properties I'm about to show you and think that it's going to be a rhombus. And we'll see why in the coming sections. This particular property says, the next property says that a rhombus is also going to have perpendicular diagonals. So in other words, if I were to construct the diagonals on this thing, okay, what this property is telling me is that these diagonals are going to bisect each other at a 90-degree angle. Any questions on that? Okay, notice that in this particular instance then, since it's a right angle, notice that we end up getting a right triangle scenario, right? So let me give you something, and I want you to find what I'm going to give you. So I'm going to tell you that this is a 30-degree angle, and I'm going to tell you that this side is 3. That part of the diagonal is 3, and I want you guys to find the perimeter of the rhombus. How can you do that? Use what we did last chapter. It's a right triangle, right? What method can you use to find missing pieces on that triangle? What should you use? I heard somebody. What? Special triangle. Yeah, you should not use trigonometry here. That was your number one mistake on the quest, was you guys were using SOHCAHTOA on a 30-degree angle or a 60-degree angle or a 45-degree angle. Those can be written in perfect square roots. I do not want a rounded answer for those. So this should be done with special right triangles, right? So to do this, does anyone remember what the relationship between the short side to the long side is, just off the top of your head? Without having to write it down. I just am curious to see if you guys have figured the pattern out.
1 goes opposite of 30.
Okay.
Square root of 3 goes opposite of the 60-degree angle.
Okay.
And 2 goes opposite of 30.
So how are we going to get to, because I ultimately want this side for the perimeter, right? Because then once I have that side, I have 4 of those same pieces, right?
Yeah.
How am I going to get to this side then? Now, I'm going to start doing a different method in class in the home base because a lot of you guys kind of need a little bit extra assistance on that. So what I'm going to do is start showing you, all right, usually we'd have a variable on a missing side, like x, right? So, one second, Megan, and then I'll see if you got it. What I want you guys to do who are kind of struggling with this is just to form fractions out of the numbers on each side. So in other words, if I'm going to try and find x, I'm going to write a fraction as x over 2. Set that equal to, and then I'm going to set it equal to a fraction on the other sides, 3 over 1. Does anyone have any questions about where I got those fractions? Make sure that you're putting the given pieces, the given information or the variables on the top of each of the fractions, and the ratio numbers that you put around should always be on the bottom of the fractions. Okay, so in this case, if I want to solve for x, what do I do? If I want to get x alone, multiply by 2 on both sides, right? If I multiply by 2, it's kind of hard for me to fit it in, but if I multiply by 2 on this side, my 2's are going to cancel, so then I'll multiply by 2 on this side, and I get that x equals 6. Megan, did you see the relationship right away? Is that what you were about to say? What was the relationship?
Well, I just saw it as the fraction of, because you have the 3 over 1, and if you don't have anything on the other side, it has to be variable because you don't have the base.
Right. Okay. Yep. So either way you get there, you need to find that side. If that side is 6, what is the perimeter of the rhombus? How'd you get that? Yep, because all of the sides in a rhombus are equal, so we can do this, right? Keep in mind that we were only able to use that special trigonometry because this was a right triangle, and we only knew it was a right triangle because a rhombus has perpendicular diagonals. Not every single parallelogram is going to have perpendicular diagonals. So you really have to watch that, okay? All right, another property of rhombuses are that their diagonals are angle bisectors. So I'm going to draw in my diagonals again. When it says that these are angle bisectors, it means that you're taking each angle at the vertices and the diagonals are cutting them exactly in half. Again, that is not a property of every single parallelogram. That is unique to the rhombus. Only a rhombus will have this angle bisector thing. That means that down here, these two angles are exactly the same as well. And then same thing along the other diagonals. Those guys get cut in half. Any questions on those markings? Okay. So those are 2 new properties of a rhombus. Right now we have 3 properties of a rhombus. What's the first one? All equal sides. The second one? Perpendicular diagonals. And the third one? Right, the one that's up. All right. So now we're moving on to rectangles. A rectangle has congruent diagonals. So let me draw on the diagonals real quick. Notice that a rectangle doesn't have perpendicular diagonals, right? If you look at these diagonals, does that look like a right angle to you? No. So remember that that perpendicular thing is unique to the rhombus only. Here, I couldn't do any right triangle stuff, right? What I do know here, though, is that I have diagonals that are exactly the same length. Now, in any parallelogram, the diagonals should bisect each other like this, right? That's the markings that we were doing yesterday or the other day, right? Okay, now when I tell you that these diagonals are exactly the same length, what can I modify about my markings? If I tell you that this is 6, what else is 6? This? Is that it? All of them, because I'm telling you that a rectangle has exactly congruent diagonals, right? So this should also be 6, and so should this. So going back, what can I modify on these markings? Huh? They can all have one tick mark because they should all be equal. Any question on that? Okay. All right, so the rectangle actually only has those two properties. The first property is that it has to have all right angles, and the second property is that it has congruent diagonals, right? So example 1, I want you to think about, is this statement always, sometimes, or never true? When you think through an always, sometimes, or never statement, what you want to ask yourself, could I draw a figure that fits this description? And also, could I draw a figure that does not fit this description, right? If you can do both, then it is sometimes true, but not always. But if you can do one or the other, then it's always or never. So for an example, I'm asking you, is it always, sometimes, or never true that a rectangle is a square? Can you draw a rectangle that is a square? Can you guys do that? I think I could. Let me try. Hold on. All right. Do you agree that that is a rectangle? What's the property of a rectangle? Does that have all 90-degree angles? So that sure is a rectangle. So I have fit something that does fit it. Could you draw a rectangle that is not a square? Is that possible?
Yes.
Is that a rectangle?
Yes.
Yes, but it's not a square. So would you say that this is always, sometimes, or never true? I would say that this is sometimes true. Because you can find one that fits it, and you can find one that doesn't fit it, right? All right. Can you draw a square that is a rhombus? So let me ask you this. I'm going to draw a square, and I'm going to ask you, is that also a rhombus? Why? All sides are equal, and that's your definition of a rhombus. So that is definitely a rhombus, right? Is it possible for you to draw a square that is not a rhombus? Is it possible for you to draw a square that does not have 4 equal sides? No. So what would you say? Is this always, sometimes, or never true? This is always true. So that's kind of your method for going through these, is asking yourself, can I draw one of both cases, right? Okay. I am telling you that QRST is a square, and I'm asking you, what else do you know about QRST as far as what properties does it have? So let's think about this in an organized process rather than just spouting them all out. A square is what kind of a thing is a square? It's a parallelogram. So should it have all the parallelogram properties? Yes. Now, I didn't list all of them necessarily because some of them are kind of being taken care of in themselves. I am saying that opposite sides are parallel, and I did miss something. Opposite sides should be parallel and also, what else? They should be parallel and congruent, and I did not type that in like I should have. So this should say and congruent. That takes care of 3 of our original statements because that takes care of the statement that says opposite sides should be parallel, opposite sides should be congruent, and it also takes care of the one that says one side should be opposite and congruent, or parallel and congruent, right? So that kind of overrides all of them. Then we also have the opposite angles are congruent, consecutive angles add to 180, and we know that the diagonals bisect each other. So there's all of your parallelogram properties. What other properties do you pick up in a square? The properties of a... Sure. And I don't remember if that's the next one I put, but we'll see. Yep. So it has rhombus properties, and the rhombus property says that it will also have 4 congruent sides, perpendicular diagonals, and diagonals that bisect the angles. What other properties does it have? It has rectangle properties. So this square will also have 4 right angles and congruent diagonals. So there's lots of properties going on. You have to make sure you keep them straight, right? I would almost, you guys, make a note card. So like make a note card that says parallelogram on the front and list the 6 properties of a parallelogram. Make a note card that says rhombus, list these 3 properties, and then kind of just run through them and make sure that you're not forgetting certain properties, that you have them all in your head. That would be a really good technique, because your problem in these is that I'm giving you so many little bits of information that you might come to a problem and be like, well, I don't know what to do with this, and it's because you're forgetting one of the properties, right? Okay, so let's move on, see if we know how to use these. So I am telling you that EFGH is a rectangle, all right? So I'm going to go ahead and draw a rectangle. Okay, I need to label my sides, or my angles. Remember to go around the figure and follow the sides. So I need to start, it doesn't matter which point you start on, as long as then you don't jump all over the place. So E, F, G, and H. It says that K is the midpoint of FH. So should I draw FH? Yeah. So K is the midpoint of FH, and I actually meant to change some of these. So let me do that really quickly. I'm going to modify a little bit of this. Instead of saying EG, I want this to say, oops, why can't I black that out? Oh, I know why. Okay, so instead of saying EG, I want FK. No. Yeah. I want that to be FK, and then instead of FH, I want that to be KH. Is what I'm going to tell you. All right. So it says that K is the midpoint of FH, so let's put that on. About where I think it is. That looks about right. Maybe a little high, huh? Try that again. Okay. So that's K. And then I need to put in the pieces of information that I told you. So I told you that FK is 8x minus 16, right? Can you guys read that okay? Or do you want me to do that in black? Okay. And I told you that KH is 6x plus 4. And I'm asking you to find EK, which I haven't put in there yet, right? So you're going to eventually be finding EK, and then from there you're going to be finding GK, right? So that would be those two chunks. How are you going to do that?
Both sides.
What do you mean by plug in both sides? Why do you know that those two pieces are equal? Well, I can have congruent diagonals, but they may not necessarily be cut in half. I'm not talking anything about angles right now. Right. And is that true in just rectangles? That's true for any parallelogram. Any parallelogram will have diagonals that bisect each other. It doesn't have to be that the diagonals are congruent, right? I could have that this piece and this piece are equal to each other, and this piece and this piece are equal to each other, but that the diagonals are totally different lengths, right? That has nothing to do with the rectangle yet. This is just a property of any old parallelogram. So let's solve it. We get 8x minus 6x is 2x. Oops. And then add your 16 over. Divide by 2, you get x equals 10. How is this going to help us find EK? Right, because here's EK, that's what I'm looking for, and KG. Megan? Okay, so let's plug x into one of the equations. If I do that, I'm going to get 8 times 10 minus 16, which is 80 minus 16, which is 64. Why does that help me with the other chunk? So what that tells me is that these pieces are now 64, right? Those should be equal and they're 64, but how does that help me with these guys? Well, I can draw you a parallelogram where that's not true. Ready? So these two pieces on the diagonal are equal, but these two pieces are shorter, right? So it's not necessarily true that if these are 64, it doesn't always follow that these two pieces are also 64. So why do you know that they are the same in this case? Brian?
All diagonals are congruent in a rectangle?
All diagonals are congruent in a rectangle. So that means that the whole entire diagonals should add up to the same amount. So these should add up and these should add up, which means these would also have to be 64 in order for that to happen. Are there any questions on that logic? Okay, let's look at the next one. In a parallelogram, the diagonals meet at a point E. And then I give you information, and I'm asking, is it a rectangle? So let's draw a parallelogram in general. I'm not going to assume that this parallelogram is a rectangle until I know. So I'm just going to draw a regular old parallelogram. Not perfect, but as good as I'm going to get it. And then I'm going to label the outside so I can see where things should be labeled. A, B, C, and D. It tells me that the diagonals meet at a point E. So that would look like that. Then I know that AE and BE are both 6. So AE, this is 6. And what else? BE?
Yes.
So that's this guy up here. I'm saying that both of those guys are 6. I'm asking you, is this a rectangle? And you need to be able to explain it, if it is or if it isn't. Tell me why. So we're obviously working with the diagonals, right? What would you want in the diagonals of a rectangle? What would you want to have happen? You would want all of those segments to equal 6, right? Do they?
Not as of right now.
Why not? But did I give you enough information for you to mark it yourself? Oops, I'm sorry. That was not supposed to happen. Here's my hint. You know it's what do you know about parallelograms?
Rectangles are parallel.
Okay, but that's true. So it could be a rectangle. Megan?
Diagonals are bisected.
Diagonals are bisectors in any parallelogram. So am I assuming it's a rectangle when I do this? I don't think so. Can I do that on any parallelogram? Can't I, on any parallelogram, assume that my diagonals are cut exactly in half? So that's not necessarily a rectangle property, right? That's just the property of a parallelogram. And so is this. So now, notice that at this point I still haven't used the fact that it's a rectangle. I put those 6s there because I said, hey, this is a parallelogram, and a parallelogram's diagonals are always cut in half, so I can extend both of those 6s. Now would you say it's a rectangle? What property do the diagonals of a rectangle have? Are these diagonals congruent? Is it a rectangle? Yeah, I didn't draw it to look like a rectangle, so I didn't trick myself into thinking it was without evidence. But technically, those diagonals are equal. So your answer to this, and remember, what I'm most interested in is can you guys explain stuff? So if you just said yes, you would not get much credit for it. You might get a point out of however many for having a correct conclusion. But really what I want you to be able to do is explain. Oops, and I'm sorry, it's going to go to the next slide. So my explanation for this is first to say, since the diagonals of any parallelogram bisect each other, I know that I can do CE and DE equals 6. You guys can look at the diagram that you have on your paper. I lost mine. But that's basically saying that those 6s, when I extended those 6s out, that was because of the parallelogram property, right? So at this point, I haven't used anything about a rectangle. I've just said, I know from the parallelogram, I get these pieces. And then I'm explaining, with those pieces, the two diagonals are 12, which means that they're congruent. I'm being very clear about where I'm getting stuff. I'm not just saying, oh, the diagonals are congruent, because I might ask you, well, why are the diagonals congruent, right? I'm explaining why I'm getting to the diagonals being congruent. And then I am going to draw my conclusion and say, well, a parallelogram is a rectangle if it has congruent diagonals, which I do. So now it's a rectangle. But I was very specific about where I got all my numbers. All right. Any questions on that problem? Okay. All right, I'm going to give you guys a second to copy this down while I talk through it. This is the extension of that coordinate problem that I was talking about that Sydney did on the board. Okay, now I'm extending it. So now what we're saying is assume that you have gone through those steps that Sydney went through and you've shown me that something is a parallelogram. Can anyone tell me really quickly what were those 4 steps to show that something's a parallelogram? Somebody other than Sydney? I already know she can do it. What are the 4 things that you're going to show me?
Slope and distance.
Okay, slope on how many pieces?
2.
2 slopes of opposite sides, right? And 2 distances of opposite sides. If you get same slopes and same distances, you have shown me that something is a parallelogram. My next question to you is going to be, great, you've shown me it's a parallelogram. Well, now can you tell me, is this just a regular old parallelogram, or is it a rhombus, is it a rectangle, or a square? Right? So here are your steps for doing that. You need to show me 4 more pieces. So at this point, we will be at a total of 8 different pieces that you have to show me in order to tell me specifically what this is. Okay? So what I'm telling you is that you need to find the slope and the distance of each diagonal. The reason why I want you to find the slope and the distance is because a rhombus, if your parallelogram is a rhombus, it should have perpendicular diagonals, right? And remember that from last semester, if you have opposite reciprocal slopes, that gives you perpendicular lines. So if you show me that your slopes are perpendicular opposite reciprocals, you have shown me that this thing is a rhombus then. You also need to check if it's a rectangle. And remember, a rectangle would have congruent diagonals, so that's why I'm having you check the distance of the diagonals. Because the distance, if they're the same, would tell you it's congruent, and then it's a rectangle. The next question is, well, Ms. Krejci, what if I do my slopes? Oops, sorry, it's going to go to the next slide. I'll go back. There we go. Okay, your next question is probably going to be, well, Ms. Krejci, if I check my slopes and I find it's a rhombus, can't I be done? Can't I just say it's a rhombus? Why would I tell you no? Why would I say that's not enough? You still have to check a rectangle. Why would I tell you that even though you found it's a rhombus, why would I tell you still have to check to see if it's a rectangle as well? Megan? It could be a square, and the only way you're going to know if it's a square is if it's both a rhombus and a rectangle together. So you have to check both. You can't check one or the other and then call it quits. Okay? Even if you do the work and you find it's a rhombus, you still have to do the distance formulas to see if it's a rectangle. Your work is going to look really, really, really similar to what you did on number 26, or what you should have done for number 26 on the last assignment. So let's look at an example. This is the last one. So really pay attention, you guys, to my notation through the problem, my steps. I want your work to look exactly like mine. Okay? All right, so for this problem, I'm telling you it's a parallelogram. So this time I'm not making you go through the work to show me it's a parallelogram first. I am just saying, here is a parallelogram, which is what you would have shown to me last section. But this time I'm saying, all right, assume you know it's a parallelogram. Without graphing, determine whether PQRS is a rectangle, a rhombus, a square, or just a regular old parallelogram. And you need to justify your answer with work. What is your first step in these problems? Draw a picture of it. Very good. You want to sketch it out so you can see where your sides are. So I would just sketch a little picture of a parallelogram. Well, that's not perfect, but good enough. And I would just put my little numbers in order around it. So what order am I going to go in? P and then what? Q, R, S. Just the way that the points are given, right? Okay. Again, I'm telling you, I've already told you it's a parallelogram, so you do not need to check a pair of opposite sides to be parallel and congruent. You're assuming that you've already done that. What I do want to know, is this a rectangle, a rhombus, or a square? So how would you check to see if this was a rhombus? What did I tell you on that last slide to do?
See if it has perpendicular diagonals.
Right, so what we need to do is be looking at this case, we need to be looking at our diagonals. So I need to check to see if my diagonals are perpendicular, right? What formula do I use to check that? Slope formula. Very good. How do I notate, whoa, not like that, that's for sure. How do I notate that I'm finding the slope? M, very good. And careful on which side you're using. So I want to use M for slope, but what am I finding the slope of? Did that show up for you guys? Uh-oh. But my other drawing did, right? Okay, give me 1 second. Okay, so like we said, we need to use the letter M to represent that we're trying to find the slope. Did that still not show up? Oh my gosh. This is so irritating. I hope that this isn't going to be a problem for the last 15 minutes. All right. Okay. Tell me if you see an M now. All right, we're good. All right. So we're trying to find the slope of what? Which side or which thing? Not PQ. PQ is a side. I'm looking at the, I'm trying to look at the diagonals, so make sure you're looking at the right points. Okay? By now I should be able to rattle off the slope formula to you guys, and you shouldn't really have to have me re-explain it. Here's the points. I'm just going to point them out. P and R. So on the top I'm going to subtract my Y values. On the bottom I'm going to subtract my X values. So that's going to look like -3 minus 1, that's your Y values, all over -2 minus 3, that's your X values. I need to see that setup, and then you can show me your work. So you'd get -4 over -5, which you would want to simplify down. If you have two negatives, you do want to write it as a positive. So yep, that would be your final answer for that. Now what am I going to compare that to? Yeah, so I lost that diagonal, but QS is what I want to compare that to. Now let me ask you this. What slope do you want to have on QS if this is going to be a rhombus? What number are you looking for? What? What is it you want? Do you want parallel or perpendicular right now? What? Did I lose? I lost my whole picture on my screen anyway. What does it say, QS? Oh, I'm sorry, yes. So it should be QS. Okay. What do you want this slope to be? No, because 4/5 would mean that you have parallel slopes, or parallel diagonals. You don't want parallel diagonals. -5/4. Very good. You want the opposite and the reciprocal. So opposite sign and the reciprocal fraction is what you want in order for it to be perpendicular lines. So my setup for this, make sure you've picked out your points. So here's my Q, here's my S. That's what I'm looking at to get 1 minus a -3 all over -2 minus 3. 1 minus a -3, these become positives, so this is technically 4, right, over -5. What is your, remember the most important part is at the end to write your conclusion. You need to tell me what this means. What does this mean to you about the diagonals? Does it mean the diagonals are perpendicular, or does it mean that they are not perpendicular? Not, because they are opposite signs, but are they reciprocal fractions? No. So for this is how you would write it. You would write PR is not perpendicular. So you draw the perpendicular line and put a dash through it to say it's not perpendicular to QS. And then what does that tell you about this shape? It's not a rhombus, right? We know that much because a rhombus should have the perpendicular diagonals. Am I done? Do I get to just be like, oh, okay, it's not a rhombus, great, I'm done. Right, so I have to check a rectangle, and I always have to check both of these. All right, so what am I going to look for, and what am I going to do to check if it's a rectangle? What formula? Distance, very good. So for the distance formula, we don't use the letter m. M specifically is for slope, so for the distance, all I'm going to have to draw is a P and an R to represent, hey, that's what side I'm looking at. Again, I'm going to assume that you guys can follow my distance formula at this point. So remember, the distance formula is the square root of, find the difference in your x values. So if I'm looking at P and R, here's P, here's R. So I'm going to find the difference in the x values, which would be 3 minus a negative 2 squared. Don't forget to square it. And then we're adding the difference in the y values between those 2 points, which would be 1 minus a negative 3 squared. I need to see at least that setup. The amount of work that you show after that is up to you. I just need to see this. From here, if you jump straight to the answer, that's okay, as long as you're just careful with your work. Please know if you lose points, if you get the wrong answer, you're going to lose points for that. But if you get the wrong square root without showing me the setup, I'm going to assume that you did it completely wrong. Whereas if you show me the correct setup, I at least know that you were on the right track. So let's show a little bit of work on this for us. I'm going to do some of it kind of just with you here. 3 minus a negative 2 becomes 3 plus 2, which is 5 squared is 25. Over here we've got 1 minus a negative 3, which is 4, adding, good, and square that is 16. So this is the square root of 41. Remember, I told you guys not to worry about simplifying for these problems. Just see if you get the square root of 41 on the next one. Okay, so now we're going to look at QS. Whoa. That should be the square root of difference in the x values is going to be 3 minus a negative 2 squared plus, and then you're going to have negative 3 minus 1 for the difference in the y's squared. Kind of go through the same thing we did on the last one. 3 minus a negative 2 is 3 plus 2, which is 5. Squared is 25. Plus, negative 3 minus 3 is a negative 4, but when you square negative 4, it's positive 16, so this ends up being the same square root. Are you done? Do you just leave it at that? No. At this point, you should give me your brackets. And you should tell me, what do you know about this? So don't even jump straight to it's a rectangle, but tell me, what did this tell you about the diagonals? What do you know about the relationship between PR and QS? It is congruent. That would be the symbol. And then you can say it's a rectangle, right? And that would be your answer. Now, let me just ask you, had this also been a rhombus, what would have been your final conclusion?
Square.
You would have said that means it's a square. If it had been both, then it's a square. Okay, here's your homework.